Nuclear Energy by Jacob Olvano and Aaron Emerson. A brief explanation of how nuclear fission and fusion works with 3D modeling software 3ds Max. This includes a visual of the process of both nuclear fission in the reactors on Earth and in the fusion reactions occurring in the Sun. There will also be an explanation of the lesser-known ways nuclear energy is harnessed. There will also be demonstrations on how the energy from both reactions are used. The most prominent example of nuclear fission on Earth is the reactors we have built here to utilize it. This is done by inducing nuclear fission in any atomic element with a mass greater than or equal to that of uranium. The reason this process is so powerful is because nuclear elements with a mass greater than or equal to of uranium are inherently unstable and will produce lots of energy when split. This will create a chain reaction that, if not used in a controlled manner, will begin rapidly consuming and releasing energy from the fuel in exponentially greater amounts, as each particle splits and triggers one or more particles and causes them to release more energy. In order to kickstart a self-sustaining nuclear reaction, some of the fuel must be hit with neutrons. The already unstable nuclear fuel will absorb the neutrons, becoming even more unstable, to the point that the atom will split apart, forming two new lighter atoms in the process and releasing one or more neutrons, continuing the process until the reaction is either stopped or all fuel is consumed. A nuclear reactor and consequently a nuclear power plant use the energy harnessed from a nuclear reaction to heat and boil water. The water is collected from an underground or surface reservoir and is pumped into the reactor building where it is heated by the reactor itself. The water in the reactor is boiled into superheated steam where it is sent to the turbines to produce power. The superheated steam turns the fan blades in the turbines. This loss of energy forces some of the steam back into water, where it is sent back into the reactor. The remaining cooler steam that has lost the majority of its energy is sent into the cooling towers. The steam, once in the cooling towers, condenses into water vapor, where it forms clouds and floats into the atmosphere. Nuclear fusion is the process in which atoms with a mass less than that of iron smash together and fuse to generate energy. The most known and relatable example of this is the Sun, in which nuclear fusion is the only source of energy. The first stage of nuclear fusion will when hydrogen atoms fuse together to become helium atoms. The second stage is when helium fuses into beryllium. The third stage is when beryllium is fused into oxygen. The fourth stage is when oxygen is fused into silicon. The fifth stage, which is only possible when a star collapses and goes supernova, is when any combination of fusions results in an atom with a mass greater than that of iron. This entire process happens in the core of a star, the only place in a star where the pressure is great enough to induce fusion. The core, which extends 1/4 from the center of the Sun, is at a temperature of 15.7 million degrees Kelvin and is where most nuclear fusion occurs. The radiative zone takes up from where the core left off to about 3/4 from the center of the Sun. Radiative energy takes several 100,000 years to escape this layer. The next layer is the convection zone, which takes up the remaining 1/4 of the surface of the Sun's interior to the surface, and this is where the plasma expands enough to act like a fluid, allowing huge convection currents to form. The photosphere, the next layer, is essentially the surface of the Sun, where the majority of energy escapes. The photosphere stays at the balmy 5.8 thousand degrees Kelvin. The chromosphere is comparable to the troposphere of the Earth, small but is the first layer of the atmosphere to the Sun. The corona, the outer atmosphere of the Sun, extends to space and is 2 million degrees Kelvin, much hotter than the surface. There are three main ways solar energy is collected from the Sun. The first is when it is collected by solar panels humans have built and turned into electricity. The second is when it is absorbed by plant life and used to further photosynthesis. And the third is when it is absorbed by inanimate objects and released as heat. The radioisotope thermoelectric generator, or RTG for short, is one of the many lesser-known ways to harness energy outside of fission or fusion reactions. It relies on the natural decay of radioactive isotopes and can produce sustained power for thousands of years.